Hi, good afternoon, and this is Naveena from the Department of Cyber Security in the Institute of Aeronautical and Engineering, Dundigal. And in my last videos, I have discussed with many routing algorithms, and I came from the subject of computer networks by means of routing algorithms, as well as the updating routing algorithms, and yesterday also that congestion controlling algorithms. So today, I want to discuss the main routing algorithms which will be situated under the routing algorithms like distance vector routing algorithm as well as the link state routing algorithm. And first of all, the first one is the distance vector routing algorithm. And the distance vector routing algorithm and the link state routing algorithm, those two are the main important algorithm which will be worked out while you're working with the computer networks. So coming to this, at the end of this video, the students can able to learn the distance vector routing algorithm in this, the type of creating the routing tables, updating the routing tables with the neighboring subnets, and the exchange of the information between the neighboring parts, and the synchronous and the asynchronous parts of the subnet, and the exchange of the nodes between the two type of subnets. Then all the things we need to discuss in this distance vector routing algorithm mainly. And what do you mean by distance vector routing algorithm? If you can define the distance vector routing algorithm, means it is an iterative, asynchronous and distributed type of algorithm. It is an iterative, first of all, asynchronous and the distributed type of algorithm. Hi, good afternoon. This is Naveena from the Department of Cyber Security in the Institute of Aeronautical and Engineering, Dundigal. And in my last videos, and I have already discussed related to many routing algorithms, and I came with many routing algorithms and by means of a congestion controlling algorithms only, parallel routing algorithms as well as the congestion controlling algorithms. Under the type of routing algorithms, the distance vector routing algorithms, as well as the link state routing algorithms and shortest path routing algorithms. So these are all the many greedy type of routing algorithms, what we can call it as a greedy routing algorithms, and which we have already defined in my last video. And today I came with the distance vector routing algorithm, which should be a main routing algorithm situated under the network world. So coming to that one, what do you mean by distance vector routing algorithm? Means it is an iterative, asynchronous and distributed mode of algorithm. What do you mean by iterative? Means, and it will be going with many successive achievements, and asynchronous means synchronous and asynchronous. Synchronous is a consecutive mode of level of transformation or exchange of the data bits from one node to the another node, and asynchronous means it is a irregular mode of consecutive transformation of the data packets or a data bits or a data frames from one node to the another node. And distributed means distributed also, it will not follow any such type of sorting order, and here and there, and the number of data packets or a data frames already they will be selected to travel by one mode of path. They can able to transfer either by means of a previous route, or if that particular path will be congested or error prone, it will be taken into the second route to reach their destination. That is nothing but the iterative, asynchronous and distributed mode of algorithm. What do you mean by distributed? The first one, distributed means it is distributed in that each node receives information from one or more of its directly attached neighbors, performs the calculation and then distributes the result back to the concerned neighbors of a source router. That means if you can take the example, each node receive information. That means if you are taking the two nodes, node 1 can able to send the information by means of a data packets. As usually according to this distance vector algorithm, the node 2 can able to receive those packets directly attached with the neighboring nodes of a source route 1. It performs the calculation whenever the node 1 can able to sends the data packets The node 2 can able to performs the calculation like how many type of data packets or data frames can able to travel on one particular path, which distributes the result back to its neighbors. That means if you can take the example of a simple logical connection of node 1 and node 2. So the node 1 can able to send the data packets from its source, and node 2 is directly attached with the node 1. It performs a calculation how many types of data packets can able to transmitted by means of a node 1, and then whenever it receives or it reaches, it will give the result back by means of a concerned acknowledgement to the node 1. So this is the main concept which should be included while you are studying or dealing with the computer networks. And second point is nothing but the iterative. What I mean by iterative? It is an iterative in that the iteration is nothing but one of the process continues until no more information is available to be exchanged between the neighbors. If you can, the node 1, if you are assuming or think, if node 1 is continuously sending the data packets, and whether the node 2 did not give any acknowledgement to the node 1, and node 1 is in the mode of thinking whether that node 2 can able to receive the type of packets which shall be sent by means of a node 1. That is nothing but the iterative, and if you can define the iterative is nothing but one of the process continuously until no more information is available to be exchanged between the neighboring nodes. That means according to our example, node 1 and the node 2. Coming to that asynchronous, it is not required that all of its nodes operate in the lockstep parallelly with each other. Here, the distance vector algorithm we can define in a secondary way. It is nothing but the dynamic algorithm, and it is mainly used or consisting of two types of protocols. What are those two types of nets? Means ARPANET and RIP. Here, each route maintains a distance table known as vector table. Here, the distance vector routing algorithm consists of one table. That table, what we can call it as a vector table. And coming to the second points of a distance vector routing algorithm, if you are dealing or studying about the distance vector routing algorithm, the three keys to understand the working of a main protocol of distance vector routing algorithm. What are those three keys? Means knowledge about the whole network, and routing only to the neighbors, and the information is received by the router. So mainly the three keys to understand while you are working with the distance routing algorithm. First one is the knowledge about the whole network. Each router shares its knowledge through the entire network. The router sends its collected knowledge, that means knowledge of packets or knowledge of information which can able to transmit through one path about the network to its neighbors. This is nothing but the knowledge about the whole network. Means each router shares its knowledge throughout the entire network. Suppose if you can take the subnet of LANs, LAN 1, LAN 2, LAN 3, LAN 4, LAN 5. It will be connected by means of one of the router. So this router shares whatever the information he or she receives. It will have a need to share that information through the entire subnet of how many LANs it should be connected by means of a one router. That is nothing but sharing of the knowledge or sharing of the information by means of a router through all its above networks or hosts. Coming to the routing only to the neighbors. The router sends its knowledge about the network to only those routers which have directly links. Suppose if you can take, this is the router 1 of subnet. If you can take the router 2 of with some WAN connections, W1, W2, W3 and W4 if you can think. So this router 1 sends its information, knowledge of information about the network which will be having the direct links. That means if you can take the example of router 1 and router 2, the router 1 is connected by means of all the LAN type of network connection, and router 2 can able to connect with all type of the WAN connections. So here the parallel neighboring routers like the router 1 can able to share the information or the knowledge which it might holds to the parallel router of route 2 by means of its direct link which should be attached with in between the router 1 and the router 2. That is the second key concept to understand the concept of the distance vector routing algorithm. Third one is the information. The router sends whatever it has about the network through the ports. The information is received by the router and uses the information to update its own routing table. Information sharing at regular intervals. That means information sharing at regular intervals. Within 30 seconds, the router sends the information to the neighboring routers. Suppose if R1 can able to share the information, whatever the information it might holds to the parallel neighboring router of R2, it will take the 30 seconds to share whatever the knowledge or whatever the information it might holds. It will have a need to share to take the time of sharing that much of information to the parallel neighboring of R2 by means of a 30 seconds. These are the three main keys to understand while you are working with the distance vector routing algorithm. So coming to this, the example of a distance vector routing algorithm with some formula. So that is nothing but it will be summarized or characterized by means of one formula. Let if you are think that dx of be the cost of least cost passed from node x to node y, if you are assuming that one. The least costs are related by means of a Bellman-Ford equation. Dx of y is equal to minimum v c of xv plus dv of y, where the minimum v is the equation taken for all neighbors like dx of y and dv of y. Here, if you can notice one point, the distance vector algorithm, the other name for the distance vector algorithm is Bellman-Ford. Why? Because, and he defines or he calculated one equation by means of calculating the least cost path from the distance vector algorithm, and the person who has introduces that equation. So hence this algorithm in a secondary way, what we can call it as a Bellman-Ford equation or Bellman-Ford's algorithm. So here, and the equation is dx of y is equal to minimum v c of xv plus dv of y, where minimum v is the equation taken for all x neighbors. That means parallel neighbors. If you are taking like the previous example of a R1 and the R2 of a total subnets. After traveling from x to v, if you consider the least cost path from v to y, the path cost will be c of xv plus dv of y. C of xv plus dv of y. Hence, if you can define the least cost from x to y is the minimum of c of xv plus dv of y taken overall neighbors with the distance routing vector algorithm. The node x contains the following routing information with related to the routing table. And again, here for each neighbor v, the cost c of xv is the path cost from x to directly attach to the neighbor of v. The distance vector, hence if you can define that distance vector d of x is equal to d of xy with y in n, containing its cost to all the destination y is in with n subnet. Hence, finally, the distance vector of each of its neighbor, that dv distance vector is equal to distance vector of y, yn for each neighbor v of x. This is one of the main algorithm steps if you can define by mode of a distance vector routing algorithm. And coming to that one, as I already explained, the distance vector routing is an asynchronous and iterative as well as the distributed mode of routing algorithm in which the node X sends the copy of its distance vector to all of its neighbors. The node of X which will sends the copy of all its distance, whatever the neighbors, it will be associated by means of a host 1, host 2, host 3, host 4 and host 5. And second point, when a node of X receives the new distance vector from one of its neighboring vector V, it saves the vector of V and uses the Bellman-Ford equation as usually to update its own distance vector. Hence, the equation, if we can define, is given below. D of xy is equal to minimum V C of xv plus dv of y for each node y in N. Hence, finally, the node X has updated its own distance vector table. That means this is the node X. It will be updated by its own distance vector routing table by using the above equation and sends it all its updated information related to the table to all of its neighboring hosts so that they can update their own distance vectors easily in a consecutive way. So coming to that, the next main equation is nothing but, if you can calculate the distance vector routing, as I am telling, that it is nothing but the asynchronous algorithm with a distributed mode, and the main equation of a distance routing algorithm to calculate or the least path of distance from one node to the another node or transformation of the bits, sending the bits from one node to the another node. If you can define, minimize the equation by means of a d x of y is equal to minimum of v c of xv plus dv of y for each node y in N. This is nothing but the main equation which would be included while you are working with distance vector routing algorithm. Here, the node X sends the copy of its distance vector to all of its neighbors. When nodes receives the new distance vector. So, hence, if you can define, the distance vector routing is an asynchronous algorithm in which node X sends the copy of its distance vector to all of its neighbors. When a node receives the new distance vector from one of its neighboring vector V, hence we can define the vector is a V. It saves the distance vector of V and uses the Bellman-Ford equation to update its distance vector routing by means of a distance vector table. Hence, the equation is summarized or defined by means of a given below equation. Here, and coming to that, the next point in the below given figure, and we have to identify one figure here. Here in this figure, and the nodes are situated like A, B, C, D, E, F, and based on that, all these are containing some net IDs, net ID 1, net ID 2, net ID 3, net ID 4, net ID 5, 6, 7, and all these are connected with A, B, C, D, E, F. Here, and every subnet or every host, it will be connected by means of a router. So, all these hosts, this is host 1, this is the 2, this is the 3, 4, 5, 6. All these are connected by means of a one subsequent router consisting of followed by which subtable of information. So, according to this one, and if you can take in the below given figure, each cloud represents the network. Each cloud, that means this represents the network, which will represents the network. And after that one, if you can take, and the number inside the cloud represents the network ID. Here, it is nothing but the network ID. Okay, next, coming to this, and the neighbors add this knowledge to their own knowledge and sends the updated table to their own neighbors. Here, the neighbors add this knowledge to their own knowledge and sends the updated table to their own neighbors. That means the neighborings. So one can able to share the information with 2, 2 can able to share with 3, 3 with 4, 4 with 5, 5 with 6. Like that only the neighboring networks can able to share the information within this total subnet, within this total subnet of network. And here, in this way, the router gets its information plus the new information about the neighbors, and routing table consists of here the two process of occurs. For the first one is the creating the table, second one is the updating the table. Initially, the routing table it was created for each router. Then it contains at least the 3 types of information, such as what are the 3 types of information providing by means of a routing table is nothing but the network ID, that means net ID, and the cost and the next hop. Suppose if you can take the table of a routing table consisting of 3 types of information, what we can call it as, it will be divided into 3 types. The first one is the net ID, second one is the cost, third one is the hop. So all these are traveling by means of in one parallel consecutive mode of iterations. Hence, the distance vector algorithm is an iterative, asynchronous as well as the distributed. In this way, the router gets all its information plus the new information about the neighbors. Okay, here the distance vector example is nothing but here if you can take the example of one distance vector, this is nothing but the network ID, and here in our previous example, so if you can take, it will represent the network, and this is the network ID. This is all these are networks are connected by means of a router, what we can call it as a subnet. A subnet is a combination of many type of switched networks or individual networks which will be connected by means of a router. So hence if you can define means, if you can define in a single way, that it is nothing but in the below figure, each cloud represents the network and the number inside the cloud represents the network ID. All the LANs are connected by means of a router. All the LANs are connected by means of a routers, and again, and they are represented in boxes labeled as A, B, C, D, F. So these are all nothing but the networks or LANs represented by means of a numbering. Suppose LANs, if you can take the example LAN represented, each and every LAN should be represented by means of a numbers 1, 2, 3, 4, 5, 6, 7. So like that only, and distance vector routing algorithm simplifies the following process by assuming the cost of every link is in 1 unit, considerably assuming the cost of every link between the type of networks, it will be linked with one another. So those are all nothing but the process of assuming the cost. Therefore, the efficiency of transmission can be measured by the number of links to reach the destination. In distance vector routing, the cost is based on the hop count. As I already explained to you that it is nothing but, and the distance is mainly calculated the number of networks which will be associated with another type of LAN networks by means of a network ID, and the links which should be present or linked with each other, and as well as by means of simply the routing process assuming the cost of every link between one network to the another network, and can be measured by the number of links to reach the destination. Here, how many links they should be attached with one network, with one another network to reach their destination. Here, if you can take the example of A was telling, and I periodically send my knowledge about the whole internet to BFE. That means A can able to send their knowledge of information or network about the B as well as F as well as the E. And B was telling, I periodically send my knowledge about the whole internet to A and C. And B was telling A to C, A and C. And coming to this, the network or the LAN connection, what we can call it as the C was exposing or telling that I periodically send my information or the knowledge about the whole internet network, that means about the total subnet, to B as well as the D. Coming to the D represents, D was telling, I periodically send the knowledge related about the entirely network or internet work to E and C. E and C. Whereas the coming to that E land subnet or a network represents, I periodically send my knowledge about the whole internet of work related to the A and the D. So each and every LAN or each and every network represents their mode of sharing the information with their parallel neighboring of networks by means of their respective corresponding links which are associated linked with each other. This is one of the example of a subnet of the network which can represents the mode of networking associated with the links which will be situated or associated with many type of internet works by means of through the subnet of networks. And if you can take the second concept of a distance vector routing algorithm, and if you can take the example, mainly as I am telling, it is nothing but the iterative asynchronous as well as the distributed mode of networking. And again, if you can take the example of the same previous example, if you can take the consideration, it is one of the second example, like by means of a network ID as well as the hope. So these are the mainly the three types of things, or at least the three types of information which should be available by means, or if you are working with a distance vector routing algorithm. The first one is the network ID or net ID, the cost, and the next hope. So next one here is nothing but the, if you can take the example of A, B and C and D, E, F, and here if you can take it by means of the A LAN of network 1, 2, 3, 1, 1, 1. This is nothing but net ID. Second one is the cost, and hope will be we need to calculate. Here also the B LAN of network under the subnet of one internet work, whereas the net ID is 1 and 4. The cost is 1, 1, and hope of the distance we need to calculate. Coming to that C, the net ID is 4, 7, and the cost it is 1, 1, and hope is we need to calculate. Again to the sixth, and the net ID is 6, 7, and the cost is 1 and 1, and the hope we need to calculate. Again like E also, the net ID is 3, 6, and the cost of the measurement is 1, 1, and the hope of the distance we need to calculate. By means of a one network to the another network, in which the links which will be, see how the links it will be associated with one another type of networks to share one of its information with other type of networks by means of a through the subnet of networks by means of a those three constraints, what we can call it as a net ID, cost, and the hope. So after that one, in the above figure, the original routing table are shown of all the routers. In a routing table, the first column represents the network ID, and the second column represents the cost of the link, and the third column is empty, which is nothing but the hope, nothing but the distance. These routing tables are sent to all of its neighboring routing tables and our neighboring links, which can able to share their information for the perspective of sharing with the other type of nodes. For example, A sends its routing table to B, F, and E. According to the before example, A can able to send to that B and F and E. B sends its routing table to A and C. A to C. Next, and C sends its routing table to B and D. B and D. Next, and D sends its routing table to E and C. E and C. Again, and E sends its routing table to A and D. A and D. Next, and F sends its routing table to one and only remaining A. F can able to send its routing table to A. This is the type of sending the information from one network to the another network through the links which should be associated among the total subnet of the networks from one network to the another network of internet routing algorithm. So again, with them by means of an example, the distance vector with the updated table, I want to discuss by means of an updated table. This is one of the second most example, and if you can take like the network ID, and second one is the cost of the link, and here the one hope, next net ID, cost and the hope. This is the hope. So it will be received from the B and adding one hope after adjustment. It will be like 1,4 and 2 BB. That means one hope will be added. So one hope will be added to this one, that 1 plus 1, 2. Again 1 plus 1, 2. And the hope will be calculated by this one, BB. After adjustment, after adding the 1 to the number of cost of links to the one hope, 1 plus 1. And again we need to calculate this much, and the result will be 2 and 2. Update the table. When A receives a routing table from B, if you can think, then it uses its information to update the table by means of it, the three types of keywords, like first one is the net ID, second one is the cost of the link, third one is the hope. Again, the next point, if you are discussing about the distance vector with the updating table, is nothing but the routing table of B shows how the packets can move to the networks 1 and 4, and the B is a neighbor to the A router. The packets from A to B can reach in one hope. So the 1 is added to all of its cost given in the B's table, and the sum will be the cost to reach a particular network. So this is main the example of a distance vector routing algorithm with an updating table. And coming to this, the second most table or the example while you are defining or dealing with the distance vector is nothing but combined table. It is nothing but the combined table. So it is nothing but, again we have to divide it number of and net ID and the main cost of link, and it is nothing but the hope. And again A's old table, which will be consisting of net ID as well as the cost of link as well as the hope. And again here the hope will be, as we have already calculated in our previous table, this is the answer what we got after adding to one table the hope. The answer will be, the resulting of the table will be this one only. So this table we want to take it here, and again we need to add this to among this the A's old table. If you can add to the hope table, then we can get the result means again 1, 1, 2, 3, 4 and 1, 2, 1, 1, 2, and this is the net ID cost of link of first one is nil, second one is the B, third one is the nil, fourth one is the nil, fifth one is the B. So how it will be, we can discuss. The combined table may contain some duplicate data in the above figure. That means here in this figure, the combined table of a router A contains the duplicate data. So it keeps only those data which has the lowest cost of path of routing algorithm. For example, A can send the data to the network 1 in two ways. That means A can send the data to the network 1 in two ways. The first, which uses no next router, so it causes no hope. One is with router and second one is without router. One is sending the information with router, second one is without router. So the second link or the second path which does not uses the route or the router, so it doesn't cost one hop. It doesn't cost one hop. And second point is nothing but the second requires the two types of hops. The first one is the hop A to B, then B to network 1. B to network 1. Here, the first option has the lowest cost. Therefore, if it is kept and then the second one is dropped. Already, it is used mainly to find the lowest cost of path. Therefore, it is kept the first one and the second one is dropped, or it will be considering the second one and then the first one will be dropped or quitted. So, this is nothing but the distance vector with combined table. So, mainly here the distance vector routing algorithm consisting of the two type of tables, what we can call it as the creation of the table, creating the table and updating the table. And what is the use of creating the table? What is the use of creating the table means the table is created for each router at least for the sake of three types of information which is available by means of a one routing table. Those three are the network ID, the cost and the next hop. These three are essential types of contents which are available for creating the routing table to calculate the least cost path of minimum distance for the exchange of the data packets or transformation of data packets from one node to the another node. And updating the table, and in the first figure we have already shown by the example of a given figure, this is nothing but the creating the table by means of one example with several type of networks. Like as I have already examplized, I am telling you that consisting of the circular subnet of the 7 represents the LANs of 7 networks and which should be attached or associated with many links. By these links, multiple links, the one LAN of work, one network can able to share the information, what it contains, what it holds with another type of networks very easily. Whenever this information can reaches to its destination node finally, then only the least path or a lowest path can able to determine very easily. This is one of the creating the table. Coming to that updating table, it is nothing but updating table means whatever the network ID, the number of a network ID plus the number of a network ID plus the cost link or the information or the message passing through on one path is equal to one hop. One hop. This is nothing but the updating the table based on the each packet of information, every packet and containing or every network consisting of these three type of keywords. Based on that only we will update the table by means of a source route A to the source route B with taking the net ID as well as the cost link and adding one hop, we will get some final result. That is nothing but the updating the table. So again, and I want to make the review of distance vector routing algorithm. Again, I am telling it is nothing but, and in another way, if you are discussing, it is nothing but the iterative, asynchronous and distributed mode of vectoring algorithm. Distributed means distributed that each node, it will be having many several nodes which will be in the mode of a distribution section, and out of these networking nodes, the information can able to pass over or shared with one node to the another node through the links which will be attached or associated from one node to the another node, performs the calculation and then distributes the information whatever it got, and the result it will be getting back to its neighbors here. And if you can take the two paths, the data packets, the mode of transformation or the message which will be going or by means of data packets or data frames from one node to the another node, it will receives or it will needs to reach to the another node and directly attach to its neighbors from node 1 to the node 2. Node 2 can able to acknowledge it again to the node 1 and then distributes the result back to its neighboring node. This is nothing but the distributed. Iterative means it is also one of the process continuous until no more information is available to be exchanged or need to share between one neighboring networks to the another neighboring networks. Coming to the asynchronous, doesn't require that all of its nodes operate in the lock step with each other. Hence, mainly, and the other name for the distance vector routing algorithm is nothing but the Bellman-Ford routing algorithm. Why? Because and he only the person defines one equation to define the minimum low cost or the least cost path by means of a distance vector routing algorithm. Hence the name or the algorithm in a second way if you can define it is nothing but the Bellman-Ford equation algorithm. Again, the three ways of understanding the working of a distance vector algorithm is nothing but the knowledge about the whole network, again the routing of the neighbors, and again the information sharing about the networking of the neighbors. The first one is knowledge about the whole network, second one is the routing only to the neighbors, and third one is the information sharing at regular intervals with a period of 30 seconds by means of a one neighboring router to the another neighboring router. And after that one, again the distance vector algorithm can be calculated by means of a with minimum vector distance and with its neighboring destinations as well as the neighboring nodes by means of a one given formula, and that formula is nothing but d x of y is equal to minimum v. It is a distance vector cost c of xv plus dv of y for each node y in n. And next one is nothing but and the routers connected by the subnet of a LAN or a networks which will be connected by means of a routers, and they are represented in boxes labeled as A, B, C, D, E, F. The distance vector routing algorithm or Bellman-Ford routing algorithm simplifies the routing process by assuming the cost of every link in one unit. The cost of every link means the mode of data transmission or the data transmission from one node to the another node, from one unit to the another link by means of the links which shall be associated from one node to the another node. Therefore, the efficiency of transmission from one node to the another node can be measured or easily calculated by the number of links to reach its successive destination. And in distance vector routing, the cost and the network ID is already be there by followed by a given number. The cost of a link will be calculated by the number of hop count. This is already the example of a one subnet of networks represents the LAN with some network along with the network ID and connected with number of the routers with giving the numbering and associated with many links with one another by sharing the knowledge or the information what a one network which actually consisting of or holds it. And coming to this one, mainly distance vector can be calculated by means of a routing table. The routing table can be consisting of two types: creating the table, updating the table. And mainly the creating table consisting of network ID, cost and the hop. And again, and this is nothing but one of the example of a distance vector example, as well as by means of a sum five type of neighboring hosts like A, B, C, D, E, F. One can able to share with their information by its connecting links or nodes. Whatever the information, a one router consisting of a or a source routing consisting until it reaches its destination, it can able to share that information by means of other neighboring nodes by its connecting links. And after that one, updating table is equal to the network ID and the cost link is equal to hope. Whatever the network ID with the cost link table, if you can add the one hope table, we'll get the answer of the final table of how many LAN networks or a networks it will be associated with one subnet of total network. It will be associated with many cost of links. So these are nothing but the concept about the clearly with the examples, and I have explained by means of a distance vector routing algorithm with updated tables and combined tables with subnet of LAN and WANs of total networking. We connected with routers associated by means of a different links. So I hope at the end of this video, the students can able to learn this distance vector routing algorithm and mainly the two types of the tables, that means creating the table, updating the table, as well as the subnet of networks and the association of LANs from one node to the another node, and the way of communication from one node to the another node by means of a links which will be attached from one node to the another node throughout the networks, and how we can calculate the network ID with the cost link effective by means of a hope. So they can able to learn all the things. Thank you for watching this video, and I hope keep watching for the next upcoming video. Thank you one and all.
Like, share and subscribe. Hit the bell icon for more updates.